Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces.
Today, we're diving into the world of high finance and artificial intelligence. We're looking at a paper that tries to answer a multi-trillion-dollar question. How can we get better at predicting stock market returns?
It's the million-dollar question, or I guess $1 trillion more accurate these days. And for decades, investors have used two main types of information to try and get an edge. On one hand, you have the hard numbers.
Right, the quantitative stuff. The paper calls these quantitative factors. Think of it like a company's report card. You have grades for things like value. Is the stock cheap compared to its earnings? Growth. Is the company expanding quickly? Quality. Is it financially stable? These are all neat, tidy numbers in a spreadsheet.
Exactly. But on the other hand, you have the narrative. The stories, the buzz, basically all the financial news, company announcements, and analyst reports. This is messy, unstructured text.
And that's where modern AI, specifically large language models, or LLMs, come in. These are the engines behind things like ChatGPT. They can read and understand human language. So this paper uses an LLM to read a massive amount of financial news for a stock, what they call the Newsflow, and essentially distill it down into a set of numbers that captures the overall sentiment or key information.
So we have the report card numbers, the quantitative factors, and we have the AI's summary of all the latest gossip and news, the Newsflow representations. The central question of this paper is, what's the best way to combine these two very different types of information to predict which stocks will go up and which ones will go down?
Because it's not as simple as just adding them together. The news can be incredibly noisy. A headline might sound dramatic, but the market might have already expected it, so the stock price doesn't move. The challenge is to find the signal in the noise.
The researchers first tested an approach called fusion learning. I like to think of this as the smoothie method. You take your ingredients, the numbers and the news scores, throw them all into a blender and see what comes out.
A financial data smoothie. They tried a few different recipes for the smoothie. One was complex, trying to intelligently weigh each ingredient. Another tried to translate both data types into a common language before mixing. But you know which method worked best?
What's that?
The simplest one. It's called representation combination, which is a fancy way of saying they just stuck the numbers and the news scores together, side by side. That's it. No fancy blending, just putting them next to each other.
So the simplest approach was the most effective.
In this category, yes. The paper suggests that in a chaotic environment like the stock market, a simple, robust model that doesn't try to get too clever can often perform better. It preserves the original information from both sources without overcomplicating things.
But the smoothie method has a weakness. Sometimes the news is just unhelpful noise. In those cases, mixing it in actually dilutes the useful information from the hard numbers. Your smoothie gets watered down and doesn't taste as good.
Exactly. So the researchers explored a second, smarter approach. They called it a mixture model. Instead of a smoothie blender, think of this as a smart chef. This model builds two separate predictions. One is made using only the numbers, the quantitative factors. The other is made using the combined fusion data we just talked about.
So you have two experts, a numbers-only expert and a fusion expert.
Precisely. And the most important part of the mixture model is a manager on top. This manager looks at the situation for a particular stock and decides how much to listen to each expert. If it seems like the news is just noise, the manager might say, okay, I'm mostly going with the numbers-only expert on this one. If the news seems genuinely new and important, it might lean more on the fusion expert.
That sounds really powerful. But they ran into a problem, right? When they tried to train this whole committee of experts and managers at the same time, things got unstable. The experts would, in a sense, talk over each other, and the model wouldn't learn effectively.
They did, and they came up with a very elegant solution called decoupled training. Basically, they train everyone separately. First, they let the numbers expert get really good at its job, all by itself. They do the same for the fusion expert.
And only after the experts are fully trained do they bring in the manager.
Exactly. The manager is then trained to simply look at the track record of the two experts and learn which one tends to be more accurate under different circumstances. This decoupled approach made the model much more stable and, ultimately, much more effective.
Okay, so let's get to the results. Did this smart chef model actually work?
It did. The decoupled mixture model was a top performer. It showed how being adaptable, knowing when to pay attention to news and when to stick to the fundamentals, can give a real edge. It was particularly good at building more complex portfolios, like ones that bet on some stocks to go up and others to go down.
So key takeaways are, simple fusion is good, but an adaptive mixture model is even better. Did they find anything else interesting?
They found something fascinating and a little counterintuitive when they tried to make the LLM that reads the news even smarter. They tried fine-tuning it, which means giving it extra training specifically on financial news to make it an expert.
You'd assume that would always make it better. A financial news expert should be better than a generalist.
That's what you think, but it depended entirely on the market. In a highly efficient market like the US, where news is absorbed into stock prices almost instantly, fine-tuning the LLM actually hurt performance.
It made it worse? How?
The theory is that the news was already priced in. By making it hyper-focused on it, it started overreacting to noise and information that the quantitative factors already reflected. But in less efficient markets, like emerging markets, fine-tuning helped. The news in those markets was more likely to contain unique information that wasn't widely known yet.
Wow, so the big lesson is that combining traditional numbers with AI analysis of the news can definitely improve stock predictions, but the how is incredibly important.
It is. A simple combination is a great start, but a smarter adaptive model that knows what information to trust and when is even more powerful. And it's a great reminder that in the world of AI, just throwing more training and more data at a problem isn't always the answer. Context is everything.
A perfect synergy of old school data and new school AI, but only when done thoughtfully. That's all the time we have for today on Daily Papers.
Join us next time as we unpack another fascinating piece of research.